And we remember from multiplication, standard algorithm just means standard steps. Algorithm's just steps. Okay, so on your worksheet, the first problem that it gives you is 9,024 divided by 93. Okay, so the first thing I would do is make myself an area model box. My dividend has 4 numbers, so I know I would need 4 boxes. And then I break it down by place value. I have 9,000. In the hundreds place, I don't have anything, so I don't have any hundreds. In the tens place, I have a 2, so I have 20. And in the ones place, I have 4. So 9,024. And then my divisor goes on the outside of my box. Okay, now, again, we always start working with multiples of 10, and we can't go up to 100, so it has to be multiples of 10. And I know, just doing quick math, if I multiplied 93 times 10, I would only get 930. That's way off, isn't it? If I multiplied it times 100, I would get 9,300, and I can't go up to 100 anyway, but that's pretty close, isn't it? So I'm going to try 90. Just right off the bat, I'm going to try 90. So I would just go to the side and do my math. I would have 93 times 90. Quick math lets me know that I can multiply the whole number parts that I see. 9 times 3 is 27. Carry the 2. 9 times 9 is 81. Plus the 2 is 83. And then how many multiples of 10 were we dealing with? Just the 1, so we add 1 0. And look, that works, doesn't it? It's a little bit less than that. Okay, so then I subtract. 0 minus 0 is 0. Can't take that from him, so he's going to have to borrow. Well, he doesn't really have enough to give him, so he's going to have to borrow from him first. So that's going to make that an 8. He would have been a 10, but he let him borrow some, so he's a 9. And then he gets the whole thing, so he's a 10. 10 minus 7 is 3. 9 minus 8 is 1. Oh, excuse me, nope. Hold up. I got off on my place value standing over here at the side. 9 minus 3, because I'm in the hundreds place, 9 minus 3 is 6, and 8 minus 8 is 0. So I have 630 left over. And we know the pattern. I take what's left over to the next box and add it to what was already in there. And there was nothing in there, so I still have 630. So now, I start looking at multiples of 10. 93. If I do 93 times 10, well, is that even going to work? 93 times 10? It won't even go the 10 times, will it? So, won't go 10 times. 0 times 93 is 0. And I subtract. And I still have 630. So, keeping with the pattern, I take this on over here and add it to what was already in the box. So now in this box I have 650. Working with multiples of 10, because I'm not to the last box yet, I can't start digging away at it. Will it go into that any multiples of 10? No, because if I multiply 93 times 10, I'm going to get more than that number. So again, it won't go in any multiples of 10. 0 times 93 is 0. And if I subtract, I get 650. Keeping with the pattern, we take this number on over to the next box and add it to what we already had in there. So now in this box I have 654. Okay? Won't go in any multiples of 10, will it? But I'm on my last box. So once you get to the last box, that's when you have to start whittling away. 9, 8, 7, 6. So let's see. 9 times 10 would have been 930. So even 93 times 9, that's probably still going to be too big, isn't it? So I'm going to go down just a little bit more. I'm going to say 93 times 8 and see where that gets me. 8 times 3 is 24. Carry the 2. 8 times 9 is 72, plus the 2 is 74. Well, that's a little too big, isn't it? So that tells me whittle away at it a little more. Try a 7. 93 times 7. 7 times 3 is 21. Carry the 2. 7 times 9 is 63, plus the 2 is 65. So that's 651. Well, that works, doesn't it? So now I know that the 7 will work, and I just did the math for it. 7 times 93 is 651, and I subtract. 4 minus 1 is 3. 5 minus 5 is 0, and 6 minus 6 is 0. So I've got all my boxes covered, and this number is less than the divisor, so I know that this is what was left over. So this is my remainder. I have a remainder of 3. To get my full quotient, I add all of the numbers on top. 90 plus 0 is 90, plus another 0 is still 90, plus 7 is 97. So 93 will go into 9,024 97 times with a remainder of 3. Now, I said I was going to show you another way today. I said, besides the area model box, working with multiples of 10, I was going to show you the standard algorithm. Okay, standard algorithm just means standard steps. So I would write it with a house, because if I'm doing standard algorithm, I'm going to be using my division house. 9,024 goes inside the house, just like on the area model. The dividend went inside the box, didn't it? And then the divisor is 93, so it goes outside the box. Okay, so now I have it set up in standard algorithm form. All right, now when we've been working with a single digit out here, we start by seeing how many times that digit would go into the first number. And hey, we do it the same way. How many times will 93 go into 9? Well, it won't, will it? So we're going to put us a placeholder 0 over that 9. And then 0 times 93 is 0. So we would subtract. 9 minus 0 is 9. And when we were working with single digits, we brought the next number down. And that's what we do since we're working with double digits. We bring that 0 down. How many times will 93 go into 90? Well, it won't, will it? So we have another placeholder 0. 0 times 93 is 0. So we subtract. We still have 90. And just like when we were doing single digit, we brought that next number down, and that's exactly what we do with double digit. All right, 93. It will go into 902, won't it? And I know from quick math, if I multiplied 93 times 10, that would give me 930. So that's a little too big, isn't it? So I'll try it times a 9. 93 times 9. 9 times 3 is 27. Carry my 2. 9 times 9 is 81. Plus the 2 is 83. So does that work? It's 837. Can I take that from 902? Yeah, that works, doesn't it? So I know that it will go 9 times. And I've already done the math for it. I know that that's 837. That's an 8. Okay? Now, can't do that, so we'll have to borrow. But he doesn't really have any to give him, so he's going to have to borrow too. So that would become an 8, and since he loaned him some already, he would be a 9, and then he would get it all, so he'd be a 12. 12 minus 7 is 5, 9 minus 3 is 6, and 8 minus 8 is 0. Just like in single digit, I bring down that final number. 93. Will it go into 654? Yeah, it will. And we know that 9 times 93, that's too much, isn't it? That's 837, so a 9's too high. So I'll go down a little bit. And I'm gonna try a 5. Okay, 93 times 5. 5 times 3 is 15, carry the 1. 5 times 9 is 45, plus the 1 is 46. Will that work? Yeah. 654 minus 465. I would have to borrow and borrow. Okay, so 14 minus 5 is 9. 14 minus 6 is 8. And 5 minus 4 is 1. So I would have 189. Well, that's too big, isn't it? That's more than my divisor, and I don't have any more numbers left to bring down. So I'd have to bump down 1. So I'll try a 4. 93 times 4. 4 times 3 is 12. Carry the 1. 4 times 9 is 36. Plus the 1 is 37. Okay, so we would subtract that out. Sorry guys, ran out of room down here. 372. 654 minus 372. Well, that's going to be way too much too. That's going to give me, I'm going to have too much left over. I'm going to try a 7. Let's try a 7. 93 times 7. 7 times 3 is 21. Carry the 2. 7 times 9 is 63, plus the 2 is 65. So 654 minus 651, that would leave me 3. Okay, so that's less than that. So that works, doesn't it? So 7. 7 is my number. We've already done the math for all of it. This is smaller. All of my digits are covered. So my final answer is 97 with a remainder of 3. Okay? So this is using standard algorithm form. Standard algorithm form. Okay? Do the next one with you. The next one on the worksheet. Oh, and by the way, I forgot to ask you